Dr. Tony Tan Keng Yam, Mr. Teo Chi Hien, Mr. Heng Swee Kiet, Mr. Peter Ho, distinguished guests, friends and colleagues. It's my pleasure to present to you today the Cooling Singapore project, which I believe is an important project for two reasons. First of all, it addresses the problem of urban warming, which, as I hope to persuade you in the next few minutes, is something that Singapore needs to take very seriously. And secondly, as we've heard, because it's a new type of CREATE project, an interdisciplinary project aimed at finding solutions to critically important societal problems. So, what is the problem? Here are 4 reasons why cities get hot. First of all, there's less vegetation and therefore less dissipation of energy through latent heat. Secondly, energy tends to get trapped in the spaces between high buildings. It's called the canyon effect. Thirdly, the cities are made of concrete and steel and stone with a high thermal capacity which heats up during the day like a bread oven and then gradually loses that heat at night. And fourthly, of course, cities are huge consumers of energy, and that energy is used and dissipated as heat. So all cities tend to get hot, and we know from previous work in Singapore, through the National University of Singapore, that in Singapore, the urban heat island effect, in some places, Orchard Street at 8 o'clock in the evening, can be as much as 7 degrees centigrade. And this urban heat island effect we measure as the difference between the temperature in the urban area and in the surrounding rural areas. And it's a problem. Why is it a problem? Well, obviously, it reduces livability. It makes the city less comfortable. And of course, it flies in the face of all attempts to promote active mobility. Ask any Singaporean why they won't ride a bicycle, and they'll tell you it's too hot. But it's actually more serious than just discomfort. A new analysis of heat-related deaths around the world confirms that these deaths are, of course, related to temperature, but they're also related to humidity. And unfortunately, Singapore has the wrong sort of climate. Because of its very high humidity, the risk of death occurs at much lower temperatures. Basically, to the right of that curve, there is a real risk of heat-related death during strenuous activity out of doors. And even now, the present climate of Singapore, there are many days, each little circle is a day, there are many days on the wrong side of that curve. And if we take the most optimistic assumptions about climate change, then by 2050, this is the scenario RCP 4.5, with moderate success in mitigation, the great majority of the year you will be in the temperature region where there is a significant risk of heat-related mortality through activity out of doors. Not surprisingly, this has major economic consequences. Analysts have identified Southeast Asia as particularly vulnerable to the effects of climate change. And out of the cities in Singapore, Southeast Asia, Singapore in particular is vulnerable to a considerable reduction in labor capacity due to this effect. So it is a significant problem. And that was the thinking behind the Cooling Singapore project, which has 4 main objectives. One is simply to gather the facts. What is the nature of the urban heat island effect in Singapore? The second is, what can we do about it to evaluate all of the options and determine which of those are likely to be most effective in Singapore? The third is to try and develop a roadmap, actionable knowledge for policymakers, so that one can chart a course in order to deal with this problem. And finally, to develop prototype web-based tools which will give the policymaker the ability to examine the consequences of different planning decisions. And CREATE, I believe, was really outstandingly positioned to run a project like this. The various entities have complementary expertise. ETH, for example, has been working for many years on how urban planning can contribute to a cooler, calmer Singapore. And it's also been looking at the value we get from greenery in terms of ecosystem services. TU München has been working on transport, closing the transport gap between the MRT and bus, and optimizing public mobility with a particular emphasis on e-mobility. And that clearly is another area in which we will find solutions. SMART has made great progress in Singapore in understanding the nature of the urban climate, and then using the models they've developed to assess the effectiveness of different mitigation measures. And NUS have really been pioneers in understanding the development of the urban heat island effect in Singapore, and more recently in looking and understanding at a related issue of thermal comfort. But academic research is simply not enough. It's important that any recommendations are policy relevant. And therefore, part of this project has been to assemble an urban heat island effect task force composed of, I think it's 10 different agencies, other experts in Singapore, including the private sector, which have the following roles. Fundamentally, to ensure the policy relevance of anything we do. But the roles include scoping the project, helping us to evaluate the different measures that we might find, formulating the vision, developing a roadmap with very clear metrics and KPIs, and perhaps most significantly, in the long term, building an expert community in this area within government. So we've worked very closely with this task force and are very thankful to the agencies for their very active participation. Now, I haven't got time to go into detail of what we've done. I'm just going to give you 5 glimpses of the kinds of results that we have been obtaining. And the first thing we had to do was to map the urban heat island effect. And immediately we have a problem. The meteorological services make measurements at 1 or 2 places. We want a comprehensive coverage of Singapore. And so we found a shortage of data. But we had the great good fortune to be able to use the data from the National Science Experiment. 50,000 odd Singaporean school children going around their business each day with a little Wi-Fi based recorder recording temperature and GPS information and many other things. And this was just a gift to us. So we were able to take these data, I think 50 million data points, plus data we discovered on the web of a sort of an army of amateur meteorologists in Singapore that we didn't know about, and then using a sort of big data analytic techniques, we were able to produce the first very detailed map of the urban heat island effect of Singapore. And here it is. This really is a triumph in a way that we were able to construct this map. And what it shows is that there is indeed an urban heat island effect. Interestingly, it is round about 7 or 8 degrees if we take the extremes from the warmest areas to the coolest areas. But it highlights the first policy issue, and that is that going forward, clearly we need a better system for being able to map and track this changing urban heat island effect. So some sort of electronic sensor network will clearly have to replace these 50,000 school children. The second thing is we need to be able to model the urban heat island effect of Singapore, because then we can ask what if questions. And here, SMART, with their work on the urban climate, has really been extremely important in the project. Essentially, what they have done is to be able to couple a numerical weather prediction model with an urban canopy model, which describes the changes in the urban atmosphere due to buildings. And so we begin with a map of the land use, of the different types of building within Singapore, and couple that with this weather forecast model, and we can come up with a map of the temperature in Singapore. But the beauty of the modeling, of course, is that we can also make Singapore a rainforest. We can completely cover Singapore with vegetation, and then we can construct what the temperature would be then. And the difference between those two models is, of course, what we want, the urban heat island effect. So I'd like to show you this, which is very new. It's about yesterday, I think we got it, so I'm hoping it's going to work. What we see here is 24 hours of urban heat island effect modeled in Singapore. We start at the break of day and dawn. when there's no urban heat island effect, it's blue, and you can see that even at the beginning of the day, there is an urban heat island effect. Here we are at midday, and you can see that it's building up in the afternoon, especially in the very dense areas. We've cut out Jurong, by the way, because we don't yet adequately cover heat from industrial processes, so we've decided to leave out that. This is still very much work in process. Now it's night time at 7 o'clock, it's got dark. But the important thing is that Singapore, of course, still has an urban heat island effect all the way through the night. And in this model, it's up to about 5 degrees. It's not exactly the 7 degrees, but as I've said, this is work in progress. And the beauty of this model is that it allows us to test what-if scenarios. So there we are. I think we're just about to get to the beginning of the day again. There we are. And so that's very important, developing our capability to model the urban heat island effect. The third thing we're working on is the issue of thermal comfort, because that previous model was about air temperature. But actually, whether you feel comfortable outdoors or not is not just a matter of urban air temperature. It's about the radiant environment. It's about psychological activities. It's about your physical activities, and so on. It turns out to be a very complicated thing. And if you're going to design mitigation measures, what you're interested in is how people feel, not what the air temperature says you should feel. And so we're trying to understand what is it that determines thermal comfort. The fourth thing that we need to understand is people's perceptions and attitudes. How do they feel about high temperatures? What do they know about the urban heat island effect? And therefore, we are doing a number of activities. One is an online population survey to ask people exactly those questions. The second one is a measurement campaign to actually come up with empirical information about the factors which affect thermal perception and also which influence whether people are prepared to take outdoor activities or not. And finally, there's also an educational element in this, an engagement campaign helping people understand the nature of the urban heat island effect. And finally, and of course most important, what are the opportunities for mitigating this effect? So we have assembled from around the world a catalogue of methods which have been used to try and reduce urban temperatures. We got 86 of them altogether, and they are grouped together here. They include shading, changes in transportation, of course, e-mobility, reduction of energy consumption, the use of new materials, urban geometry, water bodies, vegetation, and so on. There is a wealth of things that can be done. That's the good news, by the way. There's a wealth of things that can be done. But will they work in Singapore, and which will work best? And to help us answer that question, we need to look at different situations within Singapore. So working with the HDB and with the URA in particular, who've supplied us with the data, we've taken 3 very contrasting areas of Singapore. One of them is a housing estate, HDB housing estate in Punggol, and we can explore in our modelling environment how different measures might affect the urban heat island effect there. The second one is the CBD, a very different set of problems. And then the third one, working particularly with the URA here, not yet built, and therefore particularly exciting, because of course perhaps we can influence how it is built, the Jurong Lake District. And in these areas, we can do these what-if questions using our models. And this is just one little bit of output. This is a different type of model from the one you saw before. The one you saw before was essentially a climate model at a large scale. This is a much smaller scale model to look at how does the configuration of buildings, the arrangement, the materials and so on affect the local temperature. And here you can see the solar radiation and the air temperature in a part of the CBD. But the important point is there are hundreds of analyses being done like this to find out how we can mitigate this effect. So, this is a very ambitious project. In fact, it's almost a terrifying project to manage. The NRF gave us only 18 months, and trying to get academics to do anything in 18 months is a pretty tall order, let me tell you. But we're doing our best, And we've got some important milestones coming up. In fact, next week we meet for the second time with our task force and we discuss scenarios and particularly our vision for Singapore. In January, we meet with our International Advisory Board, again, to try out these ideas and make sure that they make sense in terms of what's going on around the world. In April, we have another meeting of our task force where we look at those case studies and we begin to draft the roadmap, and this is what keeps us all awake at night. By July, we want to be able to launch this roadmap at the World Cities Summit. So we are very busy. And the roadmap will consist, I think, will be a very important document. It'll be very readable. It'll explain the nature of the urban heat island effect, the phenomenon as it occurs in Singapore, the tools that we have to model it, the site-specific case studies, Jurong, Punggol, and so on, scenarios for the future, and recommendations. And that will be written very clearly for the policymaker with milestones, with metrics, with KPIs, and, of course, recommendations for future research, because it's quite clear that we are really just at the beginning of this. So let me conclude with two general remarks. And the first general remark concerns the problem of urban warming. And as I've said, the combined effects of global warming and the urban heat island do pose a very significant challenge for Singapore. And consider this, nothing that Singapore does alone will have any influence upon global warming. It's simply a matter of scale. So Singapore can do nothing, even if it signs up to the Paris Accord and fulfills its obligations to the letter. It will have no significant effect upon global warming. But Singapore can at least do something to mitigate its own urban heat island effect. And that is therefore very important. And there is good news, as I've said. There are many solutions to this problem, if we can only understand those solutions which will work best in Singapore. And I think our project is beginning to point the way to a radical rethinking of cities based upon urban climate design. And I've got this nice picture from Woha here. I'm not saying this is what Singapore will necessarily look like, but it clearly will in many ways be radically different as we embrace urban climate design. And the other good news is that if Singapore develops these solutions, then there will be many other cities around the world facing exactly the same problems, which I think will be very eager to adopt them. So there really is, I believe, a commercial opportunity as well as an environmental imperative. Then the second remark I'd like to make is about CREATE. You see, this urban heat island effect problem is an example of a complex problem that can only be addressed through interdisciplinary research and through close collaboration with the public and with policymakers. And of course, there are many other such problems that societies face. And I believe that CREATE is uniquely positioned to tackle these grand challenges. Not only can it draw upon an extraordinary wealth of research expertise, not only in Singapore, but around the world, but it also has cultivated and enjoys very strong relations with government agencies and has a real interest in implementing findings as soon as possible, and a real interest in the policy framework which makes that possible. So I believe that this is really an opportunity for CREATE, and it's been a great privilege for me to be involved in this first project. Thank you.
Great. Thank you very much, Professor Edwards. We'd now like to use the floor for audience Q&A.
Professor Edwards, if I may start the Q&A, thank you for your presentation. I was wondering, so in your discussion with the urban climate design, have you come up with specific examples of technologies or specific design recommendations that Singapore could implement, say, tomorrow to help address this question?
I think it's clear there are some low-hanging fruit which can be implemented rather soon. I think these innovations in transportation are one of them. You know, if we can move towards e-mobility, and particularly if this vision of different types of taxi mobility and so on come to fruition, that will very significantly, or could very significantly reduce the anthropogenic heat production. That's one. I think great improvements are possible in electrical efficiency, particularly for air cooling. We know that. We can halve the amount of electricity, and again, that is a very significant contribution. So those, and of course the ongoing effort for Singapore to green the city, those are all things which are good and can be done immediately. I think the real benefits, though, will come from this urban climate design, and we can make suggestions about how that could work. Photovoltaics, I think changing the basis of electricity production, and indeed perhaps even using the photovoltaics as the shading of the buildings to stop them getting hot, is an example of a kind of architectural initiative. But we're not there yet. We're not there yet with what this urban climate design will look like. There are ideas, but we're not very far advanced.
Yes.
Thank you. Do you distinguish between the contribution of air conditioning systems and the contribution of the solar irradiation to the phenomena?
Yes. The models do that. Essentially, the models sort of solve the energy-heat balance, and they consider all of the various aspects of that energy-heat balance, which include anthropogenically generated heat, the balance between short-wave radiation and long-wave radiation, convection, and so on. So the answer is yes.
How would you estimate the fraction?
The relative fraction. Well, that's an interesting question, and it obviously, that's why it's so important to have these different land use classes across Singapore, because if you are in a landed property which is two floors, then it's obvious that the energy-heat balance is completely dominated by solar radiation. If you are in a 60-floor tower, then full of servers and computer screens and air conditioning and whatnot, then the electricity, the energy through the electricity can be 5 or 6 times more than the net radiation. And therefore, it's obvious that in the CBD, the energy balance is dominated by anthropogenic. And that's really one of the reasons why increasing energy efficiency and reducing electricity is so important. In these very high buildings, the amount of energy we put into the system is currently far too high.
I think we have time for one more question. Yeah.
Did you think of vertical farming?
We haven't thought about it in this. I mean, this is a topic which I know a lot of discussion is going on, including within CREATE. And we haven't thought of it specifically in this context, but I think it does belong in this context of urban climate design. Because vertical farming offers the opportunity to have large evaporative surfaces, and therefore it seems to be something which would be very compatible with a city which is designed to regulate its climate. And of course it has lots of other benefits as well.
Great, thank you. We have one more.
Use the old technology then. Thanks for a wonderful presentation, Professor. It's always good to hear you speak. Now, I'm glad to see your circadian rhythm of the heat island, right? The only thing is that from your presentation, my presumption is that you are trying to say cool down the city throughout the whole year. I think you should try to overlay the seasonal monsoon onto your diagram.
Yes.
So that we create the annual rhythm as compared to a circadian rhythm, right? Now, I have a funny suggestion for you and your team. Instead of trying to depress the temperature throughout the whole year, I suggest look at Singapore and try to increase the temperature on the hot months and reduce it during the wet and cooler months. Then we get to feel the seasonal changes. And I think physiologically, you will appreciate both better off. Thank you.
We want it to
I know it's
snow
a big-
as well.
Well, I must be honest, that is one suggestion I haven't yet heard. I mean, you're exactly right about the seasonal course, and somebody said to me yesterday, "Oh, it's really rather cool here. I do hope it heats up by tomorrow so that they will appreciate the importance of the Cooling Singapore project." But in fact, as I said, we've just produced this model literally yesterday, and we will, of course, be looking at the seasonal course of the urban heat island effect.
Great. Well, there are no other questions. Thank you very much, Professor Edwards.